Let's go ahead and analyze this series with the ratio test. Before we can actually do that, we need to know what a sub k is. So we need to know what the pattern is with this series. We need to be able to write it in a closed form. Now, the first thing I notice is that the denominators are powers of 6. So we have 6 to the 1, 6 to the 2, 6 to the 3, and then 6 to the 4 is 1296. We also need to figure out a pattern for the numerator. It's not totally obvious, but when we look at 32, that's a number we're pretty familiar with, and that is 2 raised to the 5th power. Now we know right away that these other numerators are not powers of 2, so let's not focus on that 2. Let's focus on the 5 for a moment. Let's focus on that. Because we certainly could write this as 1 to the 5, that numerator of 1. And if we look carefully at 243, we notice that, oh gosh, that is 3 to the 5. And so then we check 1024, and sure enough, it is 4 to the 5. So that tells us that our closed form, our summation notation for this series, is going to be k equals 1 to infinity. We're going to start at 1. And we will have k raised to the 5th power divided by 6 raised to the k. So now we have our a sub k. So we can form the ratio that we need for the ratio test. So we're going to come down here, and r is going to be the limit as k goes to infinity of a sub k plus 1. So that means replace all the k's with k plus 1, divided by a sub k. Well, that means multiply by the reciprocal. And you may be thinking, hey, what about the absolute value bars? Well, we don't really need those because everything inside there is positive. So let's go ahead and focus on the 6's first. Those are a little bit easier to peel apart, and what we notice is that there's 1 extra 6 in the denominator, so I'll write that as 1/6. And then with the k plus 1 and the k, we see that they have the same exponent, so we could write that as k plus 1 to the 5th divided by k to the 5th. And in fact, maybe what I'll do in one fell swoop is just write this as k plus 1 divided by k, all raised to the 5th power. Now, the limit can push inside of here, and the limit in here is 1. K plus 1 over k has a limit of 1. These have equal powers, so the ratio of coefficients is what the limit will be. 1 to the 5th, well, 1 to the 5th is 1. So this whole part here is going to approach 1 as k goes to infinity. And then 1 multiplied by 1/6 is 1/6. With the ratio test, we compare this to 1. That is less than 1. Therefore, the series is going to converge. So for the ratio test, if the limit of that ratio is less than 1, you have convergence.